Officially, you're all welcome to today's session. I am Ahonia Obed, and in cohort 7 of the program, and I'll be taking you through a session on load balances. As I always do, I try to connect things that you already know to things you don't know so that it makes it easy for you to understand. And that is what I'm going to be trying to do today. So when you talk about load balances, what exactly are you talking about? I think from the name, you may be able to infer something from the name, even if it is your first time of coming across the concept, load balances. So it's coming from two words, right? We have load, we have balances. If we are saying load and balances, the layperson could easily interpret this as balancing of load, right? And it will make a lot of sense if they say balancing of load. And let me explain how this works. So, for those of you who have no idea what load balances are, we're actually talking about when you are dealing with service, all right? When you are dealing with service and the load that the service carry, we want to be able to balance the load that the service carry. But for those of you who also do not even know what servers are, essentially servers are just computers that provide particular services, all right? So you could look at it from that angle. Any computer that is made to provide a service could be referred to as a server. And when we host websites, we host applications and all, we usually do those on a server. And when you try to access it, so right now we are using this medium for our meeting, that is using Google Meet for this session. Google Meet is being hosted on a server that belongs to Google, right? So we are able to have access to it because Google server is currently actively serving us what we are requesting for. This streaming service that is on them is working because their server is active. But imagine the number of meet sessions that take place in a day, all right? Not only us, I mean the whole world, how many meetings as such is going on. If you take a platform like Google Meet, a platform like Zoom, or even let's use a very common example that we all know, Google or ChatGPT as it may be, now that almost everyone is using it. These are services or platforms that people, thousands, I mean, 100,000s or even millions of people are accessing in a day. So now you ask yourself, how powerful are the servers to be able to handle all this load? Obviously, they will not be using, I mean, they will be using servers that are very powerful, but you should be able to infer that they could get to a point where the load on these servers are too much for the servers to handle. So remember that I said a server is just what? A computer that is performing a particular service. So it cast your minds to your own computer. If you are using your own computer as a server, then there are times that your computer freezes, right? There are times that your computer freezes. So let me put on a diagram to illustrate something, a basic one. Say this is the server from Google, right? Server. So this is Google server. And this is you, your computer, trying to access google.com. So imagine if Google had server, just one server. This server obviously has a maximum capacity that it can take, irrespective of how huge the server is. It will definitely have a maximum capacity that it can take. That is to let's exemplify it using your own computer. When you take your computer has a maximum size in terms of the storage size, in terms of processor speed, and all of those things, RAM size and all. There is a certain maximum that it can take, beyond which your computer begins to lag or freezes, okay, or becomes unresponsive. So in the same way, if the number of requests going to Google, let's assume within a particular second we are having 1 million requests going to Google server, and if the maximum that Google server can take at a time is say 10,000, then this is going to be problematic. So what will Google have to do? Ideally, you're either going to increase whatever maximum you are looking at. If it is storage size, you are going to either increase that storage size, or you are going to add on some other service, right? So there's a concept known as scaling. We'll probably look at that later and I'll explain it. But the problem is now we are seeing a lot of people are trying to access Google, right? And Google server has a maximum of 10,000. Please, these are arbitrary values that I'm using. I'm not saying these are facts. I'm just using them to explain concepts. So please follow. If there are 1 million requests per second, then this server is becoming overwhelmed. So what we'll do is we'll now introduce a couple of other service in order to handle the workload that is coming on the server. But the problem right now is, even though we've added multiple servers, everyone that is surfing Google is hitting a particular IP address. Remember that computers are identified with their IP address. So let's assume this is 198.2.8.2.1. That is the server. Once again, it's just assumptions that I'm making to explain this thing. So let's assume that this computer is the server that Google is using. And for that matter, even though we have realized the problem, which is, oh, the server is being overwhelmed and therefore is not performing as well as we want it to perform. So we have introduced new servers. But unfortunately, it's just this IP that is available publicly. So everybody is still hitting the server. How then do we avoid this problem? Okay, so let's bring it to something that you're already aware of. Then I would use that to explain load balancers and how they solve this particular problem. Let's use the traffic warden or traffic cop, or however they call them, people who direct traffic. Okay, so assuming that initially there was just a one lane road, the road was just one. Sorry, from moving from A to B, let's assume that it was just one path. And the place was choked, like there's a whole lot of traffic, as if you are on Lagos Street, I mean, or Accra, any busy place. I mean, from one point to the other, it was so choked to an extent that movement is not easy at all. So government thinks about it and decides to introduce other bypasses so that others who are probably, maybe you are coming to point C, you could branch off somewhere here and get to point C. Somebody coming to point D could also branch off here and get there, and the likes. Okay. So say we have this other one and this other one. Because now initially it was just one way, and no other person has informed anyone that, oh, we've now created extra roads so you can use this road, or this road is less busy so you can use that road, and anything of that sort. We'll still continue to have that being choked, but then we can then decide that, okay, let's position a traffic cop somewhere at the junction to direct the traffic so that we no longer have that choked path that we had. Okay, the road becomes less congested, or less number of people in traffic. So this traffic cop is going to be the one directing the cars. Okay, you go this direction, you go this direction, depending on how choked the place is, and wanting to make sure that it is less choked for most of the people. So in this case, with the help of the traffic cop, we are able to get rid of the traffic that is there. Okay, the congestion that the traffic has caused, we are able to reduce it. This traffic cop, who is now directing people to the right direction to go, can be related to what we are calling load balances. So let's say our LB, load balances, representing it with LB. We now put in an LB, and the LB will now distribute the traffic. So whichever traffic that is coming in, the LB will now see, okay, you that are coming in, for now, let me push you to this server or that server. Okay. So in the same way, the traffic cop was using his senses to now check, okay, this is more choked than this place. So let me free up this place. You people should keep moving. Those who are going straight, go. Those who are going right, stop. Like he uses his own senses to check, oh, okay, I think now it's okay for these people to move and these other people to stop and all of that. In that same way, the LB should have some mechanism to also sense which of the servers to send the request to. I hope that makes sense. So our LB, you can see him as just someone who is directing traffic. The traffic coming from people. So there are 1 million people searching something on Google at a particular second, okay, per second. And we have brought in a load balancer. So remember, the requests that are going through that we are referring to as traffic is also considered as load, the load that is going to the servers. Now we've brought in a load balancer to balance this load for us. So the load balancer should have some kind of mechanism to determine which of the servers should I send this particular request that is coming into, and it should be fast enough to be able to distribute all of the response, all of the traffic that is coming in, right? Oh, I hope I'm not speeding. I want to be able to break it down to an extent where everybody understands. I hope I'm not speeding. Guys, are you able to follow?
Yeah, I'm following just fine, sir.
All
Very
right.
explanatory.
All right, great. All right, so let's go on. That mechanism by which the load balancer would now use to determine which server to send a request to or to send a particular traffic to is known as the algorithm that the load balancer uses. So it's a very important one that we need to pay attention to. We'll discuss that later, but just remember, the just as the traffic cop needed to appreciate which road is busy or less busy so that they will know where to direct it, we have to have our load balancer have that kind of sense to be able to also determine which of the servers are probably less busy or which of the servers they should send it to. Okay, and that is what we are saying is an algorithm. Like you have to, when you are establishing the load balancer to use, you now have to tell it or implement a particular algorithm which the load balancer is going to use to figure out which of these servers should I use or should I send this particular traffic to. And as I said, we will talk about some of these algorithms. So now let's look at why are load balancers important in the first place. So we've captured the concept of load balancers, and at least now you know that they help us distribute traffic so that we don't get congestion on just one server. There's a lot of load. If there's a lot of load coming on our servers, then there should be a way for us to distribute that load. We balance the load so that we don't overwhelm a particular server. For that reason, we could say that this will help us improve performance of our servers. Okay, performance. Very important. I mean, if there is too much load on a particular server, then the performance is going to be affected because your server, which in this case is a computer, begins to lag or freezes, becomes irresponsive. So imagine if Google used only one computer to serve all of us who are trying to reach or find something on Google. At a very point in time, there's going to be the Google is going to be very slow in getting back to us because the server is overwhelmed and all. For as long as it is not happening, then you should know that there are things or measures put in place to prevent this. And one of these measures that are used by bigger companies like Google is the use of load balancers. If you are using just a single server to serve just a couple of users, then you may not need a load balancer. But if you want to maintain performance when you have high usage levels, then you need a load balancer. So performance is very key. When we talk about performance, that should bring us to, is this misdirected? Sorry. That should bring us to a concept that we call availability. availability. So for those of you, I mean, if this is the first time you are learning about load balances or anything like this, one thing you should know that these are important concepts in DevOps. So anybody here who is interested in getting into DevOps engineering, there is something very important, and eventually you may have to master it very well. It's also important concept in cloud. Okay, so cloud engineers or solutions architects, this is very important to you if you ever want to get there. Those are the people who will be playing more with the servers, right? Those who are in either ops, or you are in DevOps, or you are in cloud engineering. At least those are the basic ones that I can think of right now. And once you are going through ALS, especially if you have entered the DevOps portion and you've gone through that training, you get a basic understanding or basic knowledge to be able to carry on, so that subsequently you can decide to become a DevOps engineer, cloud engineer, or any of those related fields that you may want to choose. So the reason I bring this up is that availability is a huge topic in all of these. Okay, whether you're looking at cloud or you're looking at DevOps, is a very important concept. And availability just means that you are available when you are needed, right? So if I say my servers are available, for instance, in AWS, I think they will tell you about the 11 nines or so. So 99.999999 or something percent. So tell you that a particular service on AWS is this number available. Okay. And all they are trying to say is that 99.999999% or of the time you are likely to have the service running. So the service, or in this our case, the server is going to be running as much as we need it to. Like anytime we are looking for something, the server is there. It is available. Okay, so it's available for us to access whenever we need it. So we could say we say they are available when the servers are accessible to us when needed, right? Anytime we need it, do we really access it? Like, is there an off time? So I think that is also, or a downtime. It's also a terminology that you come across a lot when you're talking about availability. So in essence, we use the terminology high availability to let us, or to paint a picture of how available something is. So in essence, when you are building an architecture for hosting any of these services, let's say you are building a network to host your service so that you provide the services that are being rendered. Let's say you are a cloud or a DevOps engineer in Google. We are interested in how available the service that you have made available, how the servers are available. Okay, and we use the concept of high availability to explain them. So if you are saying that a server is highly available or has high availability, then there should be less downtime, right? Downtime is like a time when the computer isn't active or is not working. Then you could say that you're having a downtime. Like I believe this is something we have all experienced in one way or the other. There are times that your computer has just frozen, it's not responding. Sometimes, personally, I've been experiencing it of recent times where I've used the computer for almost the whole day, and all of a sudden it's more of giving up on me, it's not responding. So we could say that I'm having a downtime. But if you say a service is highly available or high availability, then we want to make sure that as little downtime as possible, like we have as little downtime as possible. So when you are a cloud engineer, or especially an architect, and you are architecting some of these structures, you'd have to pay attention to that. This structure that you're architecting in the way that you have chosen, with all the utilities and tools that you are using, how much downtime should we expect? And it should even be in your plan that you cater for it. During downtime, what exactly are we going to be doing? Are we using backups and all? Okay, but let me not confuse you. Stay with me here. Performance, we are looking at, load balancers help us improve the performance of our service. By so doing, we say they make them highly available, or they provide or provision our service to have high availability. High availability simply means that there is less downtime. I believe that going forward, if you see these terminologies anywhere, you will appreciate what they mean, right? Performance, your computer or your server, whatever you're talking about, is performing at its peak the way you want it. Highly available, that means that anytime you need to access that server, it is available for you. It is there, like you can access it. You don't hit it and, oh, server is too busy, it's not responding. No, it's available anytime you need it, or as much as possible, and therefore we can say there is less downtime. This also provides us with another importance of load balancers, is it provides us with reliability. So once again, reliability is a terminology that you would come across often when you are doing DevOps or cloud engineering or architect in cloud. Okay, when you're architecting structures in cloud. And sometimes it confuses a lot of people in regards to what reliability is and high availability is. But reliability, if I say you are reliable in this sense, that means that you get the work done. Remember, availability was I have access to you when I need it. Okay? But reliability is you get the work done the way it's supposed to be done. So getting the work done the way it is supposed to be. I hope it makes sense. It's a bit confusing, but I'm trying to explain it in a way that you all understand it. So availability is, hey, this guy is always available. He's always online, so I can hit him. I can hit him up. I can send him a message. But then when I send him a message to do something for me, does he do it? So that becomes reliability. So if 100% of the time this guy, when I send him a message, it goes through, like the message goes through, it's always delivered because it's always online, then I can say this guy is available. But if apart from just going through, this guy is always responding with the solution to whatever I've sent him, is doing the work that I'm expecting of him at any point in time, then I can say he is reliable. Okay, very important. So when you are dealing with your servers, you have to know when your server is available, when it's reliable, and you have to architect your solutions to be both highly available and reliable. Very important. So I hope we are getting the difference, that gets the function, it performs its function as it's supposed to do. Then you say reliability. So we can have services or servers that are highly available but less reliable. That means that even though they are live, we can hit them, they are not giving us the response that we need when we need it. Maybe there's so much delay on them. It is live, we are sending the request to them, but they are not giving us, or the results they give us is wrong, or anything like that. Then you can say that this server is not reliable. Pretty much close, but there's a difference. Available, you can access it. Okay, so when I try accessing this guy online and he's never there, some of you who have my WhatsApp contact will attest to it. I'm hardly on WhatsApp. So you send me a message on WhatsApp and I'm not there. Okay, so that is availability. The person is not available. But reliability is, for as long as the message reaches the person, does the person do what, or let's say respond to the message? Okay, because some people will give you blue ticks, and in that case, they are not reliable, because even though the message went through, they were available, they didn't respond, so they are not reliable. I hope that makes it simple, because the first time it was being explained to me, I mean, I hardly could understand it. So that's why I'm spending a lot of time on this. But I hope you are getting the concept. Any feedback from the audience, let me know if it makes sense so that I can move on.
Yeah, I
Okay.
think
Yeah,
when you
Doc.
were explaining, so from the point where I met the class, I've been able to understand your explanation. But I
All
don't know
right.
the
Good.
concept we're actually talking about in general.
Ha 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 ha. All right. Anyway, let's continue. You will appreciate it. Yeah. So we are talking about load balances. All right, and the essence of load balances. So two major things: load balances improve performance. They improve reliability. So when you're architecting solutions or setting up networks for running various services, you'd always have to consider performance and you have to consider reliability. And one of the tools that you want to use to achieve that is a load balancer. So assuming you have multiple servers, you can use a load balancer to balance the load that is coming in or the traffic that is coming in. You distribute the traffic to all the servers so that at least performance is at its peak. You have high availability. Then each of the servers are able to also give you the kind of response that you need at any time that you reach it. So that is reliability. And it also helps us scale up. All right. So scalability is also a very important terminology. Scalability. In essence, I mean, scalability means we could scale either up or down, scale up or scale down. So when the traffic is high, we should be able to scale up and accommodate the traffic. And I mean, from the beginning, I shared an example that if, let's say, Google had just one computer and we were all hitting that computer, remember that by the day the number of users of Google is going up, or let's use ChatGPT, by the day the number of people discovering ChatGPT is going up. So assuming they started with only one server, now there's a lot that is happening. People are discovering you. I mean, the huge traffic coming in, and you have just one server with no load balancer. That's going to be disastrous. So with the power of a load balance, you are able to scale your traffic. I mean, the traffic that is going up, you are able to manage it. So it's improvised for scalability. But then this is it is not the only solution. I mean, for all of them that I've mentioned in regards to high availability, reliability, scalability, load balancers are not the only solutions or tools that provide these ones. I mean, when you're architecting a correct solution or a very complex solution, you may add additional tools or additional services that will offer you, that will make your system or your network as robust as possible. But all I'm saying is that the load balancers is one of such tools that you can use to achieve that. That's very important. Okay. So yeah, you can consider scalability as one of them. Then to make things more robust and make your system survive well and all, there is a concept also known as redundancy. Redundancy. And most of these things, I want you to see them as just normal English words that have their normal English meaning. So in English, if you say something is redundant, what does it mean? Redundant, something that is, I mean, is probably not being used, okay, or less used. So you can incorporate redundancy into the concept of load balances if you want to make your system as robust as possible. Because now, when we have only one load balancer here, right? Only one. It means that all the load is coming up onto our load balancer. Well, we may have the load balancer having the scalability feature, so it's able to scale to contain the spike in traffic and all. But then what if there is a problem with this load balancer? What becomes of our system? The whole system breaks down. As soon as the load balancer breaks down, remember the load balancer is the one that is to direct the traffic where they are supposed to go. So anyone here, the only IP address they have access to is the IP address of the load balancer. In this particular case, if you have a setup like this. So as soon as this load balancer goes down, we no longer have access to any of the servers because these servers are internal. They are not exposed to the public if we are using a setup like I've described up here. So for that matter, sometimes it's important to incorporate redundancy into your setup. And all it means is that you may have to have some standby load balancers as well and configure it such that as soon as this one goes down, it will be routed to this. And this will also have that similar capability or mechanism to route the traffic to the requisite or the specific server that it needs to route it to. I hope it makes sense. So 3 terminologies that I've mentioned, or 4 of them: high availability of performance, reliability, scalability, redundancy. So redundancy comes in when you want to make your system more robust. It comes, almost all of these things come at an extra cost, right? But if you are looking at building a robust system, or servers or networks that are able to withstand huge spikes in traffic, then this is something you should be willing to pay for, or spend on. Very, very important. So companies like Google, I'm using ChatGPT because it's a new sensation and almost everyone is being introduced to it. For those of us who are using the free versions of ChatGPT, you realize that there are times that you go and the site is not available. They tell you that their servers are busy and all, and that the number of users, is huge. So whichever service they are using to host their servers, they have to spend a lot of money to ensure that all of these are available. There's performance, there is reliability, there's scalability, there is redundancy. There are other options, or there are other terminologies that you would come across when you begin to learn or delve deeper into architecting solutions like this, or DevOps in general. Okay, but not to bore you, I just need you to appreciate these ones and how they apply to load balancers. Then we can move on. Great. So now let's talk about the load balancer itself, or types. Well, what are some of the types of load balancers? If I talk about load balancers, what exactly do they even look like? We've understood the concept of load balancers, but what do they look like? Are they like mobile phones? Are they computers? Are they sheet of papers? Like, what exactly do they look like? Okay, so there are different types of load balancers, and depending on the resource you are using to read, you may come across one thing or the other. But essentially, a load balancer could be more of a hardware device. Okay, something that you can feel. It could be a physical product that is being configured to serve the purpose of a load balancer. Remember, the purpose of a load balancer is just to be that intermediary thing that distributes the traffic according to a particular algorithm that is set for it. Okay, so whether it is a shoe that has been configured to do that, you can't use a shoe to do it, but I'm just trying to make it obvious that we could have a physical device. Okay, so the types, let me write that down. The types of load balancers: we could have a hardware device, so hardware, LB. We could also have a software that is being used as a load balancer. So the difference here is that with the hardware, it is a physical something, a physical object that you can touch, right? With the software, you can't touch it. But you can install the software on probably a computer or a device, then use it as a load balancer. Then of recent times, we have a lot of cloud LBs, which personally I consider them as software LBs, but then some references will put them apart. Please give me a second. My mom keeps calling me, please. Okay, thank you, and sorry about that. Yeah, so some people have bad internet connectivity. So if your video is on, kindly turn it off for their sake. so that there is no breaking in the transmission. Excuse me. I hope you're enjoying the session just as I'm enjoying it. It's been a while since I did some, but then I'm feeling it. I should be doing more of this. Okay, so there are cloud providers that provide a lot of these load balancers. Okay, so sometimes some references will put them apart, like say, hey, we have cloud LBs, but essentially it's more of hardware and software. Okay, so it's either you have like a physical gadget that is being used or configured as a load balancer, or you have a software that you install and that software plays the role of a load balancer. Okay, so those are the common ones that you come across. And what we will be dealing with more is the software load balancer. And I believe those of you who have already done the load balancers may have come across it. You have to install some software for that purpose. In fact, let me just go ahead and give examples, which the common example that I believe those of you on the call from cohort 9 and do I say below or above? I mean, cohort 8, cohort 7 members, you have already done it, will be HA proxy. Who can guess where the HA is coming from? I mean, if you've not read about it before, but those who have read about it, I hope you know where HA is coming from. At least I have mentioned it somewhere. Are you seeing what I'm seeing? The HA. I mean, I'm doing this for the sake of those who have not seen it at all, like those who have never heard of it before. Okay, so I guess you probably saw where the HA is coming from, which is very important. Exactly. All right. So another one that you may come across is Engine X. You could actually use Engine X as an LB. So pay attention to that. It's not just used as a web server. In fact, anything that can be used as a reverse proxy can be used as an LB as well. Maybe a topic for a discussion some other time. But then anything that can be used as a reverse proxy, and if you've done your web service by now, you have read about Engine S and you know that it can be used as a reverse proxy. And for that matter, I'm saying you can also use it as an LB. Okay, and there are even, I mean, there are these LBs that we are talking about. Like now, they are being given extra functionality so that it's not just the load balancing that we are talking about. They are bringing on functionalities like caching, like, and a couple of other functionalities that are being woven into it. Okay, but at least if for nothing at all, you should know that these two are tools that you can use as load balancers, so that if you are setting up anything at all, you'll be able to use. I got introduced to load balancers. The first one I got introduced to was what we call ELB. It is Elastic Load Balancer. And this is from AWS, Elastic Load Balancer. So we would put this under the cloud load balancers, right? But they decided to call DS Elastic Load Balancers. I think yesterday I came across one from Google, I've forgotten the name, but essentially all these cloud providers may have their own tools that perform the role of a load balancer. Okay, so irrespective of the tool that you are using, you should understand the underlying mechanism or the exactly what they are doing, the functionality. All right, the name of the tool doesn't matter, the tool itself doesn't even matter. It's a similar concept throughout. So once you appreciate what it is and how it works, then you'll be able to use it irrespective of the tool that you are using. Okay, in our case, we'll be focusing more on the HA proxy because that's what in the ALS program, that is what you are introduced to, the HA proxy. So we'll focus on that. Now, let's talk about algorithms. I mentioned earlier that comparing our load balancer to a traffic cop who is directing traffic, The traffic cop was using his senses to see that, oh, okay, this road is choked, so now you guys come in this direction to stop. Then the others should move because their road is free. So let's release that congestion. They use their senses to do that. The load balancer should also have a means to also determine which of the servers to send it to. And I said that means or mechanism by which they do that is what we call an algorithm. So there are a couple of algorithms, the LB algorithms. And even these LB algorithms, it depends on the specific LB that you are using. Okay, so if you choose one LB, it may have certain algorithms that the other does not have. So let's go on. The HA proxy, some of the algorithms that you have access to with the HA proxy, which is quite similar for almost most of the LBs you come across. The first one, which is the default algorithm available in HA proxy, is the round robin. Round robin. So remember, I said this is like the census that the LB or the load balancer has to be able to determine which server to send it to. When you use the round robin algorithm, simply what it does is that if there are 4 servers, it goes through them in a cycle. Like, so say this is 1, 2, 3, 4. When it starts, let's assume you have an LB here that is interfacing the traffic that is coming or the load that is coming here, assuming there is a load coming in here. We need to be able to distribute it. What happens when you are using the round robin algorithm is that it goes round, it shares it round robin, shares it round, okay, like in a circular fashion, go up to the point when you started and keep going, like keep sharing like that. So it starts with 1, then the next request that comes in is sending it to 2, the next one will be sent to 3, the next one to 4, then it keeps repeating the cycle again. Start from 1, the next one goes to 2, 3, 4. So round robin isn't, it's like that algorithm is very simple. I mean, if you have, especially if your servers are serving the same kind of stuff, like the same information that is being provided by the servers, then you could use the round robin. Okay, it tries to do some sort of even distribution, but then there are times that this is not like the best choice. Okay, if you have a simple infrastructure, the load isn't that much, or your servers are producing the same outcome all the time, then you could use that, especially if the servers are of the same nature. So if, let's say, this your processing speed is 2 gig for each of them, then you know that, oh, this is fair enough. I mean, they all have the same processing speed, so I'll distribute it equally amongst them. Because there are times that one particular server or some of your servers have huge capabilities than the others. So when you are using this algorithm, then it's not the most effective. But simply put, just understand that the round robin algorithm will do some sort of circular distribution. It starts from 1, then it continues. It will not jump any, irrespective. Even if it comes and you are as busy as what, it would still give you the request or the traffic or the load that has been scheduled to come to you. So it starts first 1, the next one goes to 2, the next one goes to 3, the next one. The way I'm counting it, you see it as a slow process, but this is not slow. I mean, this is how a computer works, right? You know how computers work. When you put in a call, the call goes through some of these things. I mean, it depends on which servers are being used to serve these calls that you're calling. Right now that we are on this session, okay, it depends on which servers are being used. And it's done in a couple of, I mean, microseconds. Okay, so you wouldn't get to see any delay or any sort of thing. But what we need to appreciate is how the distribution is done. And in this case, if you are using round robin, then it means we are going to 1, then from 1 we go to 2, 3, 4, then back in that order. So that is essentially what round robin is. Another algorithm that we can talk about is least connection. So essentially, an LB using the least connection algorithm what it's going to do is going to check for the server that has the least connection at any point in time. Then it will send a request to it. So you remember how I told you that, sometimes this is not the most effective because maybe this request that you send to server 2 is yet to process it, and or is being delayed. Server 2 is delaying. So this is looking for amongst all of these before I send it to them, which of them has the least connection currently, so that I send it to them. They don't have more work, so that I can easily send it to them, and hopefully they should get it done for me. So this is depending on your use case, it may be a better option for you. So least connection is essentially the load balancer has an algorithm. It checks to see which of the servers that is serving has the least connection at any point in time. Then it will choose to send the request or forward that particular request to the one with the least connection. So that is for the least connection. We have another algorithm called the IP hash or the hash algorithm. And essentially, when you say the hash algorithm or IP hash in particular, what is happening is that you take the person's IP, wherever the load is coming from, take the person's IP and hash it. The concept of hashing, hopefully some of you already know about the concept of hashing. If you have done the hash maps and hash tables, you would appreciate what hashing is. But anyone who has even dealt with passwords should know what hashing is. Some sort of encryption, okay? But then what is happening here is that if they give you the IP address, say somebody's IP address is this, you have a particular algorithm that converts this. Okay, so let me use the word encrypt if it would make you understand. Okay, but it hashes this and gives you a particular outcome, and it directs all specific hashes will go to a given server. This is very important. Let me say, let's say we are using two servers, okay? Then we have two different people trying to reach this server. Say this is 128.78.2.1. This is the second person. So if you are using the IP hash, when this one gets to the load balancer, this IP address will be hashed. And assuming that when it was hashed, we got something like, I'm just saying, we got something like this, okay? And it determines that, okay, let me send this to this particular server, server 1, and this is server 2. Then when it hashes this, it sends it to server 2. What this means is that any point in time when this particular user is trying to access the resources on our service or our service, is going to automatically land the person on server 1, okay, all the time, because we are using the IP hash. Unless it sometimes when you go to the detailed part of configuring the IP hash, you may do some things that sometimes may change it and all. But on the basic level, let's appreciate it from this level. It is such that it's always going to hash it and the function will always result in the same output. And that output is always associated to a specific server. So this client will always land on server 1, okay? And this client will always land on server 2 if that is how your hashing algorithm was implemented. And this becomes useful in cases where you need, the person probably has some session, the person has logged into the system, and you need to remember the person. You remember how when you are signing up or logging into some applications, they ask you to tick this to remember me, that remember me checkbox, so that at any point in time you don't need to log in again because you already have access to it. If you are doing something like that on your service, then you don't want to be using something like least connection or round robin, where they are going to be changing consistently anytime that you try to access it. This one is going to be consistent, that once it is coming from that same IP address, then they are going to remember that this particular IP address was used and it's always going to be hashed to this value, and this value is always associated to this particular server. So that is the essence of using the IP hash. And as I say, when you go to the nitty-gritties, I mean, there may be some changes here and there, but just have a general overview, and I mean, we are good to go with that. Okay. All right. So which other one should we talk about? There is another one called the least response time. Okay. I mean, there are a lot of these. We can't talk about every one of them, but just remember the common ones that we are talking about. So the least response time is like the LB, or the load balancer, works in a way that it tests the servers that are available. So if there are 3 servers, it's going to test all the 3 servers and see which of these give the least response time. That is the fastest amongst them. Remember, the initial one we spoke about was least connection. So this had nothing to do with the response time. The least connection, it was looking at which of these are connected. I mean, which of these now have a lot more traffic. So it was looking for the least one, the one that had the least traffic to it. That was just the number of connections to the server. So if the server has 1,000 people and another server has just 200 people connected to it, then it's going to route the next person to the one with 200 because it has the least connection. But when we come to the least response time, the LB on itself will have a test case. Okay, so before anything, it throws the test case to all the servers and gets its feedback. It measures the time at which it gets the feedback. So if they spend 3 seconds, they spend 0.2 seconds, and they spend 0.004 seconds. Okay, then you know that it's going to route the next one to the server because it had the least response time. I hope all of these things make sense. It's simple. I mean, I believe that I'm trying to break it down very much such that it's simple so that you understand. Round robin, you have to go around in a circular order. I mean, give it to them irrespective of the load they are having, provided it's their turn. I mean, it's my turn, give it to me. It's my turn, give it to me. It's my turn. Like that. That is round robin. You go around the table, let everybody get their own share and start all over again. Keep sharing until there is no traffic. That is round robin. Least connection, look at them. Which of these is busy? The one that is least busy, give it to the one that is least busy. They don't have a lot of connections, so give it to that particular one. IP hash, any IP that is coming in, hash that IP, and the hash that you get should be always be connected to a specific IP, a specific server. Okay, so I believe those of you who have done hash tables, you would appreciate exactly what is happening. Okay, so it hashes the password, and every time that it hashes the IP address, and every time that IP address tries to access your servers, it gives it to a particular server. And I've explained the importance, especially when you are using sessions, to keep the details of a user so that they don't have to probably re-log in all the time. Then the least response time is it uses an algorithm that will always try to hit all the servers available and see their response time. So hit them, get when did I get a response? The one that is the fastest. That means at that point in time, this is the one that can deliver the fastest. And I want fast. I mean, I want it fast. So I'll send it to that. And that is the least response time. One interesting thing is that you could actually have a combination of these algorithms, all right? So you could have an LB that uses a combination of all some of these, okay? And it's all boils down to the configuration. And not every one of them is possible with every type of load balancer. But once you are aware and you are aware that there is an algorithm that you need to set, then depending on your use case, you will now come to analyze which of these do I really look for? Am I looking for something that is of least response time or least connection? Then you go ahead and use it as such. So we could have multiple combination. I don't know, someone else to have their hands up. I Will they be able to speak? If they'll be able to speak, you can go ahead and ask your question. Otherwise, put the question in the chat. Let me see if there are any questions.
Okay, you can speak now.
All right, sure. So, anyone who has a question, go
Hello.
ahead. Hi.
Hello. Okay, so please, I want to ask: is IP an abbreviation for something?
Oh, IP address. As in,
Okay.
if it is an internet protocol. So,
Okay. Thank you.
yeah. So I was just referring to that. And but you could even think of it generally as just the hash algorithm and how it works. So depending on this specific example that I use is hashing the IP address. So you could have an algorithm that hashes something else, maybe the MAC address of the device that is accessing it or anything. Okay, but specifically the IP hash that is commonly used. Any other question?
Yes, doctor, how are you?
I'm good. Yourself?
Good. So, sorry, I joined late. I found you talking about the high availability
Okay.
and reliability. So, did you get a chance to talk about how to deploy multiple load balancers for redundancy?
So I think I try to explain the concept of redundancy and why it will be needed and all, and try to relate it. But we're not doing more of a practical session where I could illustrate how you are deploying it. Okay, but then it's essential in most cases because now let me just mention ones that has come up. So there is a concept called single point of failure. Single points of failure. SPOF, if you find it anywhere. Single point of failure. If you want to make a system highly available, you should get rid of any single point of failure. And essentially, what a single point of failure means is that there is one point in your setup such that when that point breaks down, the whole setup breaks down. Nothing is going to work. So in an example, if we have just a simple setup where the client is trying to access the resource, this is your server, okay? This is your server, and it's just one server, there is no intermediary, and we are all trying to reach it at the same time. This is a single point of failure because when the link, this server, breaks down, that is it. We can't access your service any longer. So you'd want to prevent single point of failure if you expect, high load, you want your system to be as robust as possible. And I already mentioned that all of these things comes at a cost, right? You have to be willing to spend money in order to get all of this. So you probably will go and get extra servers. So now you've gotten two servers and you want to balance the load between them. So maybe with the help of an LB, you are able to do that. It's not just an LB that you can use to do this. There are a couple of things that you could use, but LB makes a lot more sense because it helps you to balance the load. Right. Now you have removed the single point of failure from this end because if this server goes down, this other server will still be available to serve. And probably if the server goes down, this may be available to serve. You could add as many servers as you want, okay? But then you've moved the single point of failure to this end because the IP address that this person is trying to access in this setup, in this particular setup, all of these are isolated from the public. Nobody in the public knows the IP address of this, and nobody knows the IP address of this. So that is also another advantage of using a load balancer. Now you are able to keep your servers away from the public. It is going to prevent various attacks on the servers themselves. Remember, the LB is available publicly, so there could be various attacks, maybe a DDoS attack on the LB. It's possible. Attackers may want to attack this, but eventually they will not have access to the server itself. Okay, so at least it improves security. So you could think about it in that way as well. Your LB can help you improve security by now keeping away your servers. But unfortunately, you still are having a single point of failure, which can affect availability. Anytime you talk about single point of failure, you are looking at availability. Okay, those of you who would ever want to go and write AWS cloud practitioner exams and even the solutions architect exam, these are two important things that you should know. Anytime there is a single point of failure, availability will be affected. What it means is that at any point in time, if let's say there is an attack on your LB and it breaks down, your whole setup is broken. Nobody will be able to access anything. And you want to prevent that. So you may want to add on other LBs and maybe not make them active. We have the passive active or master slave type of connection. Okay. And I don't really want to delve into those things right now, but essentially what is happening is that you have one that is actively working, as the load balancer. But if there is any problem, let's say there is an attack on this or there's a breakdown of this LB, then this LB's function will now be passed to this. So it still keeps working. I mean, your setup is still functional, nothing is broken. In that case, we can say that you've eliminated a single point of failure. Okay, so anytime you're doing a setup and you want it to be as robust as possible, you want to do everything possible to eliminate a single point of failure. And one of the ways you do that is by using providing multiple options to the various devices that you'll be using. Once we are not using this actively, it introduced the concept of redundancy, as I mentioned earlier. And I keep saying that all of these things, you should take them as their English words and what they mean. Redundant means something is there and it's not being utilized, okay, or it's not fully utilized, all right? So essentially, that is what is happening. Does that answer your question?
Okay, thank you. This has been informative. What I was asking specifically, did you cover, okay, I have had challenges in deploying redundant load balancers in the past, okay?
No, okay.
So I wanted to know which methods do you use, or if you have ever deployed load balancers, multiple load balancers, more than one. How did you overcome the challenges that we usually we usually encounter?
I mean, I want to believe that I've done some before, but it's been a while and I clearly do not even remember a lot of the things I did. I think when I was going to write the solutions architect certification, I did a lot of practice with these things. So if it is more of a practical session, maybe we could have some time to deliberate on it and see essentially how to do it. But I use more of the AWS Elastic Load Balancer, and mostly it's quite simple. I mean, you don't do a lot of. Even when we're doing it, I didn't know about algorithms and the likes. I mean, a lot of these things that I'm explaining, I learned it when I was doing. I mean, I came to understand or appreciate when I was doing that of ALS, but you note it. I mean, if it is something that's bothering you, maybe when I have some time, we can go through it.
Okay, thank you. Because we usually have a lot of challenges. The two main methods that are used is the DNS method, whereby you create multiple A records pointing to the different IPs of the load balancer. So the same, maybe www.obed.com, but it is pointing to two servers. But now the problem with that is caching of DNS, okay? The other option is to use a virtual IP, but that also has many of its challenges. So maybe if you get time, you can research for us.
Sure.
Then in our next practical session, we can try and implement, and we see, because this is something very important, having multiple load balancers so that you can avoid points of failure. Yeah.
Yeah.
Please,
I mean,
when are we going to have our practical session, please?
that I can't really say right now. I mean, something that we'll have to think about. Yeah.
Okay. Now, the second one is about the types of load balancers. Yeah.
Okay.
Okay. For some of us old people, old timers in the industry, we usually classify load balancers into three categories. The
Okay.
first one is an application load balancer. The
Oh,
second
okay.
one is a network load balancer. And the third one is a combination of application and network.
That's right.
In your case, I have seen you prefer to call them based on the hardware and the rest. What
The hardware,
what is
software, then cloud. I mean, that's why I said it depends on the resource you are using. Okay,
okay?
because
Okay.
I think if you read from these people, what's their name? The people who use droplets. Oh my goodness. That
Digital
when you are
Ocean.
doing Digital Ocean, exactly.
Yeah.
Yes. When you are reading from Digital Ocean, I think they used to classify them a bit differently. When you talk about the what is it? The application level, the network level, they used to, I forgot exactly how they classified it, but they didn't call it type. I mean, these are just terminologies, but for as long as you appreciate exactly what is happening, okay, because how they work, I mean, the level at which they work, if you are using, say, the OSI model to explain this, then you can look at it from that angle. So is it a layer 4? Is it at layer 4 that you are considering it? Or is it at layer 7? So that becomes the application level and all. But sometimes, I mean, when I'm teaching, I look at the audience to be able to make mention of certain things, all right? And this is a fairly new audience, and I wouldn't want to go into things that will look so weird. I mean, if I have to now start talking about OSI model, I need to even explain what the OSI model is and all for them to appreciate it. So probably that's why I didn't even think about talking about that in the first place. Yeah, but I mean that's also there.
Okay. Thank you.
You're welcome.
Hello, sir.
Yeah.
Yeah, I have a question. Does the speed at which the server sends back a response, does it stay
Mm.
constant or it decreases as the load increases?
I mean, obviously, it doesn't stay constant. Like, see it from this angle, your computer, the response, the way your computer reacts to usage, is it always the same? It's not the same. I mean, sometimes it's fast, sometimes it's slow, especially when the load, there's a lot of load on it. Obviously, it's going to be a bit slow, but it all depends on the capacity. If you are underusing it, then at that point, you may be getting the same response time, or I mean the speed. Okay, so if it is being underutilized at a point, you may be getting consistent speed. But at a point when it's maybe being overused or close to its max, you realize that it's beginning to slow down and all, but it can be inconsistent sometimes.
Okay, thank you. That's my question.
All right, you're welcome. Any other question? Sure. Oh, oh no. Oh no. Yeah, no. Don't mistaken it for saying no. I'm talking about ALS students. I mean, I have, I mean, experience with these things like as a solutions architect. Okay, so I look at the audience not meaning cohort 13 or cohort whatever. I mean, I've gone through the ALS model. I know what is required. That's why I'm not bringing those things up. Yeah, so that's exactly what I referred to. Okay. Yeah, you're welcome. Okay, are we good? Any other question? Any other question before I get into the latter parts?
Okay,
Was there a
so
question in the chat? Yeah, go ahead.
so for cohort 13, because I'm also a member of cohort 13, are we going to have
Okay.
this as a future project or something?
Oh yeah. Once you're in ALS, you're going to do it, unless if you drop out. So you're
No,
going
no,
to do it.
I'm not dropping out. Okay, so
Okay.
it's actually nice to at least hear most of these terminologies, even if
Okay.
you don't completely have an idea about it. So,
Yeah. I mean,
okay,
sometimes this is what I personally do. I expose myself to things that I do not understand. Okay. And to an extent, it has really helped me master a lot of things, because now the next time you are hearing about load balances, it wouldn't be totally new, wouldn't be strange. I mean, you start reading and it makes sense. Oh, so this is what that guy was talking about. Oh, okay. That time I didn't understand it this way. Oh, no, it makes sense. You know, so for me, I never deprive myself of knowledge, whether I appreciate it or not. Sometimes I sit through like a whole 2 hours long tutorial and I just don't know what they are doing. But hey, I'm listening. I'm just eager. Okay, what then they did this? Oh, okay, and what came out of it? All right. I do that all the time, and personally, it has helped me. So yeah, I mean, I'm an advocate for that. You don't need to be in cohort 9 to learn. I mean, you could be in any cohort. In fact, somebody who is here to start ALS can even decide to learn these things. Okay, fine.
thank you very much. Thank you so much. I appreciate.
You're welcome. All right. So I think if there are no questions, we can move on. Mute everybody. I hope I didn't mute myself. All right. Now let's keep going. So there's one important thing that I didn't mention, and I was expecting that somebody will bring it up, but then, I mean, maybe you all know and you didn't ask, or maybe you're here to think about it, so you didn't ask. One thing is that there's times that it's important for you to put in some checks. I mean, your LB has to put in some checks, all right? Because what if the server is down? What happens? If this server is not working, will it still be sending requests to it? All right. And how will you even know that it is working or not? So some LBs allow you to set what we call health checks. Okay. They allow you to set health checks. Health checks. At least the HA proxy will allow you to do that. Health checks. And all this does is under the hood, it tries to check if a server is well, like if a server is healthy before it sends requests to it. So as soon as a server becomes sick or dead or unresponsive or anything, I mean, it's not well, then the load balancer will stop sending requests to it. Very important. Okay, if you don't configure it like that, it will keep sending and not pay attention depending on the algorithm you are using. If you are using a round robin algorithm, that should says that it should go around the table. It will keep sending a request, even though the server is dead, because you didn't put in place that health checks to check it for you. It would keep sending these things, but mostly like in a more advanced setup, you would want to implement your health checks. You would even want to set up monitors for your load balancer to even be monitoring exactly what is happening on your load balancer. You have monitors for your servers as well to be monitoring. And if possible, you even set triggers such that if this server goes down or this server hits its maximum CPU usage, they should trigger an alarm or something. Like, I mean, you would actively be paying attention to this. So if let's say you are the systems administrator, you're the one behind the computers, you are seeing all of these things, you have to be, these are key, what I can call key performance metrics that you pay attention to. Okay, key performance metrics that you pay attention to and you report on that. and that will tell you whether your servers are down, they are not down, like depending on exactly what you are looking for. Is it memory that you are paying attention to? Is it processing speed you are paying attention to? Is it storage that you are paying attention to? All of those things will have to be considered, but putting in place health checks is a very important thing that you would have to think about when you are doing such a setup, so that they don't keep sending requests to a dead server. The server should be alive and responsive anytime requests are being sent to it. Okay, so let me round up by getting into configuration of HA proxy. Let's talk about how to configure something like that, then we can bring the session to an end. I'm getting tired at the moment. It's been a while since I did this, so going for more than 1 hour is stressing me out. Anyway, it's fine. We signed up to do this. We got to do it. So to configure HA proxy, I think this is, let me go back for an ALS student to appreciate this. Yes, let me explain something. You are given 3 services. You are given 3 services, at least squads, 9 members, 8, 7, 6, 5, whichever cohort. You appreciate these things. Web, was it like this? Web 01, Web 02, if only I remember correctly, and LB01 or something. Yeah. What I need you to see, which a lot of people couldn't picture, is that these servers that you are given, essentially they are computers. Okay? They are just computers. So see them as such. Fortunately for you, these are not like physical computers. They are just virtual computers. Okay, so you may not see them like that, but see them as such. They are virtual computers. So if I gave you a computer right now, you could choose what you want to do with a computer. Okay, you choose what you want to do with a computer. Nobody cares. Your computer right now, all the softwares that you have installed on it is totally on you. I really don't care what you have installed on your computer, for as long as it does the work that we need it to do. So the 3 computers that ALS gave you, they now told you that for 2 of the computers, we want you to turn them into web servers, right? So this was a web server. And how did you turn it into a web server? By installing Engine S. This is the application that you use to convert a computer to a web server, right? You did same with this as well, web server with Engine S. Then you were given a 3rd computer. This time around, we don't need it to be a web server. We rather need it to be a load balancer. And remember, we've talked about the types of load balancers, and you are aware that we have software load balancers that we can install for a device now to become a load balancer. So one of those softwares that we've talked about is the HA proxy. So you go ahead to install HA proxy on this computer, and by doing that, it converts this computer into a load balancer. Then you now configure this load balancer to serve traffic to this or that. As simple as that. So essentially, that's what you were doing. If you went ahead to not install this and rather install Engine S and use it as a web server, it's totally up to you. But the request of the task or project that you were given was for you to convert the LB01 into a load balancer. So that computer, that will be its role, just to direct the traffic. So your domain that you bought, I remember I bought ehonia.tech. Your domain that you were given for free, let me not say but, so that it sounds as if I paid for it. You were given for free. You have to direct it to the IP address of this computer. Remember, every computer is accessed with its IP address, right? So an IP address. The same way, this is also a computer. It has an IP address. So all you need to do is to set your DNS to point to this particular IP address. Then you now have to configure HA proxy such that depending on the algorithm that you use, it will either send the traffic or the load to web 1 or the server, web server 1 or web server 2. So now our interest is in how do we configure this, assuming that we've already installed HA proxy. I mean, if you've not installed it, installation is not difficult. You can use the package manager apt-get, right? apt-get to install HA proxy. So probably sudo apt-get install HA proxy, and that will help you install it. Before you do that, you may want to update your package lists. Okay. Oh, so after you've installed it on this particular server, I mean, all of those things, you've done your SSH into the server, you have access to the server, you run this command to now install it. Now we need to configure this load balancer. We need to configure it for it to play the role of a load balancer. Open a new sheet. Okay, so you'll have to first find the script, the config script, okay, or where the configuration file is, then use that configuration file. You would make changes to that file. All right, and the configuration file, I think, is called haproxy.cfg configuration. So you have to look for where this file is, open it, and you either open it with, what is it called, Nano, Vim, any of the editors that you have access to, you can open it there. So I could do sudo Vim. We need a path to this file. The path, I think, is in the etc. Please, I don't have this thing off head. Let me see, etc haproxy. Before somebody thinks that I'm pulling all of this from my head. No, these things, this information, they are available on, I mean, if you need it every second, like just a couple of seconds, you would be able to pick it up, okay? So sometimes you don't even need to kill yourself to remember every one of them. What you should remember is that, oh, there is a config file where you would be doing those configurations. And now look for where you get the config file. If it is something that you are doing on daily basis, it will definitely come in handy. You will remember it, okay? But I, for one, since I did that project, and that was in 2022, I mean, I think November or December, since I did those projects, I haven't gone back to it again. So you don't expect me to have them off head like that, okay? So you should be fine if you don't have it off head. That's all I'm trying to say. But then now I've written it here. So simply you use Vim or any text editor of your choosing to open this particular file, and that is where you get into the configuration. So now, more importantly, let's talk about the configuration. To configure your load balancer, there are two major things you need to pay attention to. We have what we call the front end and the back end. It's interesting. Front end and the back end. See this as your load balancer. The front end, its function is to listen to it listens to any traffic that is coming. Okay, so we'll set the front end to be listening. Obviously, if you are talking about networking terms, you would hear listen to the incoming ports. Okay, so those of you who have learned about these things will appreciate it. We set the front end to be listening to a given port or a particular instruction or traffic. If it gets that particular traffic, then it should now route it to the back end. Okay, so it will be listening. As soon as a traffic that matches whatever you have set under your front end configuration is obtained, it will now begin to route that traffic to your back end. And the back end is where we have like access to a pool of servers. So assuming we have, say, about 4 different servers, you configure the back end to now direct this traffic that is coming to the right server. So depending on the algorithm, so in the back end, you now have to tell us what algorithm you are using. Very important. Remember, when you need to access the service, you are going to use a particular algorithm. So is it a round robin algorithm you are using? Is it IP hash you are using or any other algorithm? You have to tell us when you are configuring your back end. So for your load balancer to function properly, you go into your haproxy.cfg, that's the config file of your load balancer, and configure both the front end and the back end. The front end is the one that is facing the client, whoever is trying to access your service. That is the front end facing them. So the front end will be listening for the load that is coming and pick it up and say, okay, it matches what I'm looking for. Then if it matches it, it will route it to the back end. And in the back end, you have configured a fleet of servers that the back end should route the request to based on the specific algorithm that you state. So it is in the back end that you now tell us which algorithm you are using, then list all the servers that are available. I mean, when you say the servers that are available, they are computers. I keep saying this thing so that it syncs very much. These are all computers, right? Computer 1, 2, 3, 4. And we identify computers by the IP addresses. So in your back end configuration, you would have to tell us the IP address. In certain cases, you may have to even rename it, give it a particular name so that it will now say, okay, this one that is coming based on this algorithm, let's go to 1, let's go to 2, let's go to 3. For HA proxy, the default algorithm used is round robin. So if you go ahead and use HA proxy without stating the algorithm for your backend configuration, it's going to use round robin. And essentially all that it does is to go to 1, 2, 3, 4 and continue back to 1, 2, 3, 4. It goes around the table and share everyone in that order. Remember, in ALS, you are just being introduced to this concept for you to have a basic understanding of it and all. That's what you were exposed to. So we didn't do a lot with it. You just configure using round robin, then you tested it to make sure that it was working, and that was what that you did. So for your front end configuration, I mean, in your configuration file, you just have to look for the parts that you have, or if it is not there, I don't know if it is there by default or not. If it is not there, then you have to write it. But then you are just adding the front end and give the front end a name. It could be any name that you want. I mean, I remember I used to call mine, say, Obed front end. But it could be anything. I mean, you choose how you call your front end. Then after naming the front end, you now go below it. I think you should leave some space, a tab or something. Then you configure, you say it should be listening to a particular port, right? So you have to tell it what IP address. Sometimes you may want to restrict the IP address that has access to your load balancer, or you make it open to any IP address on the internet. It depends on the setup that you're having, whether it's an internal or like one that is exposed to the public. So in that case, you'd have to use, there's no arrow, please. I was just indicating space. So you bind this to an IP address. Using asterisk means all IP address running on a particular port. So I think we were asked to use port 80. So that means that any IP address that is running on port 80, this front end will respond to it. So any traffic at all that is coming in, irrespective of the IP address, for as long as they are on port 80, then your front end is going to listen to it and now pass or route it to the back end. You can go ahead and set the mode. The mode, if you are using 80, port 80, the mode should be HTTP, right? HTTP. That will be the mode for your port 80. Then now you tell us the back end. So if you are using just, I mean, a fleet of back end, so you could go ahead and give it probably the default back end, something like that, the default back end. Then it depends on how you call your back end. So if I called it service, Then I'll pass servers here. So this is essentially the configuration that I'll do for my front end. It's as simple as that. I told it this is my front end. I called my front end Obed front end, or whatever you decide to call it. Then the rule. So let me just say this is the rule. Very important. Your front end should be listening on a particular port for traffic that is coming in. So you're binding all the traffic the IP addresses on port 80 that are coming in. So it's going to listen to this particular one, any IP address. So if there is any of them that is coming on a different port, say port 443, it wouldn't match this. Okay. But once it is on port 8, it's going to match this. And when it matches that, using the mode is HTTP, it will now send it to the default backend that you set. That means that when it goes to the backend, remember I said this will route it to the backend. When it goes to the backend, because we have called this service, you've called this service, it means when you are defining your backend configuration, which you also do as such, say backend, you give it a name. That name should match what you told the front end. Here you told the front end that the default backend that it should pay attention to is what? Service. It's called service. For that matter, you would have to call your backend service so that you can get access to this particular backend. And in the backend, you go ahead and also, I think this particular one is optional. I'm not too sure about it. But you go ahead and mention the mode, which in this case matches with this HTTP. Then you tell us what is the algorithm that is being used. So to tell us about the algorithm, use the keyword balance. Then what is the algorithm? So the default one, which you are going to be using in the ALS program, is round robin. You just go ahead and say balance round robin. Then now you have to list the servers that make up this particular backend. So remember in this diagram, I told you there's server 1, there's server 2, there's server 3, server 4. Okay, so you have to list all of them, their IP addresses, so that it can now use round robin to route the traffic to the respective servers at any point in time. So assuming we had 2 servers, you can go ahead. Your server that you are speaking to is, call it, say, server 1. Okay, so server 1. And server 1 has the IP address of 192.28. Remember, when you were doing your own, you could have called this web 01, right? That's the names that you were given. Web 01, and you were given an IP address, so you would get that IP address as well. Then you come to the next one and say server web 02 and maybe 138.28.07. At least this will get you started. This is a backend configuration, but if you want to implement the health checks, as I mentioned earlier in HA proxy, you can just go ahead and add checks here. Okay, and I forgot the ports. So they are running on port 80, so you should add port 80. Then check would represent that, I want to use health check. So at any point in time, they should check that the server is actually active before they go ahead and route the traffic trace. So essentially, these are the 2 major configurations that you do with HA proxy. Then once you've done these configurations, you are good to go. You can either restart it you stop it and restart, or refresh it. If you want to restart, what do? Sudo systemctl, right? That should restart it. CTL restarts HA proxy, and that should restart it for you, and you're good to go. Now all the traffic coming in here, you have set up a front end that checks if it is an IP address running on port 80, then it's going to route it to either web 1 or web 2. But it's using the round robin. That means the very first request that comes in, say the first person trying to access ahonia.tech, which was the domain that I used here, The first person trying to access it, in this case, will be sent to this particular computer, the one with this IP address. Then the next person, or if I refresh again, I'm trying to hit the server again, then it will now route it to this, okay? Sometimes there are certain mechanisms which you'd want to use to prevent the excessive hitting to the server. So one is caching. I've mentioned it before, and I think, oh, okay. DevOps, did we do anything like caching? I don't remember if we did anything about caching, but essentially caching is if there is an information that is not frequently accessed, you could keep like some sort of records locally so the person has access to it, and it's a kind of speed up the work. I mean, in backend specialization, we are doing caching, not extensively and not regards to service per se, but then at least it introduces you to caching. So those of you who will be doing backend subsequently, you learn about it. I think I'm feeling tired the more. Okay, so at least these are the basics that you need to know. There's a couple of other things you can do in the front end. For instance, we could set up the front end to listening to multiple, how is it called, multiple service backends, or let me call it that way, multiple backends, and it depends on, like, let me quickly just mention this, not to go into detail in it, but then we could set other rules that will tell us which fleet of backends to send a specific command to. So for instance, maybe on my website, all traffic coming in saying ehonia.tech/blog, I want all of these things to be routed to a set of servers which have content relating to my blog on them. Then ehonia.tech/say profile, I want all requests coming through this to other set of servers that have content relating to my profile. Okay, so these are like separate backends. So this particular backend has two servers. So maybe I'll call this server one. No, server fleet one. Let me say, or pool one. Then this would be server fleet two. Just to illustrate something. So in your front end, you can set up rules such that requests that are coming in with this particular ending /blog should be sent to this particular backend. And this backend is made up of web one, server one, server two. And if it is profile, then it should be going to fleet 2, which is server 3, server 4. That's possible with the help of what we call ACL or ACL. That is access control lists. I hope I'm not boring you people with all of these things. But yeah, this you could set up ACLs that will tell that, oh, okay, anytime request is with /blog, it should go to this fleet of backend, or /profile, it should go to this fleet of backend, or maybe the default server, any other thing aside these things should go to the default backend that we set up. I think this is a good point for me to pause and probably take your questions before we end the session. So yeah, guys, I've come to an end of my talking. Now, let's take your questions, if you have any questions. Oh, how do we get to unmute everyone? Please try and unmute everyone for me. Let them ask their questions. In the chat, do you have any questions?
Yeah, good evening, sir.
Good evening.
Yes, sir. I really appreciate this section, sir. Thank you very much, sir. But there's little difficulties. Like, I'm trying to understand the difference between injects and load balancer.
Okay.
All right, sir.
All right. So, earlier, sorry. earlier on I mentioned something that the Engine X, as you know it, is popularly known for its work as a web server. Remember, when you install this on your computer, your web 01 and 02, I keep saying that web 01 or 02, which we call servers that ALS gave you, they are essentially computers, and you choose to do what you want to do with it. So you installed Engine X on them. By installing Engine X on them, you've turned them into a web server. And what a web server is that this software now allows your computer to serve web pages to people. So if somebody is trying to access a particular web page, because you have Engine X on it, they will get it. They open a browser and they are able to get it when they hit that IP address of the server. If you don't install Engine X on it, but you have web pages on that server or that computer, nobody will be able to have access to it. So you need to install Engine X, and by installing Engine X, it turns your computer into a web server. So right now, this your computer that you are using to join us right now, you could actually turn that into a web server and set up Engine X or Apache, whatever web server application you are using. You set it up in there, and people can have access to websites that you have created locally on that particular computer, provided they have the IP address of that computer. Okay, so that is what Engine X does. But then additionally, these two, as you see it, Engine X, in a way, has an extra functionality called reverse proxy. It can work as a reverse proxy. And a reverse proxy, one of the functions of a reverse proxy is technically is load balancing. So to an extent, you could actually use Engine X as a load balancer. Okay. But in ALS, what we did was our focus was use Engine X as your web server. So just for the purposes of serving web pages. So now forget about all of these things. They are not part. What you care about is that your Engine S is used to serve the web pages. It's a server that is used to serve the web pages. Then you brought in HA proxy, which is a load balancer. What does it do? It balances the load that is coming across the two servers that you have. So you have web 1, web 2. But anytime somebody is trying to access this particular web server, that web server that you created with the help of Engine S, to get the website that you have on it, then your HA proxy will now determine this particular one based on the rules that you set for the front end and the back end configuration. It will now tell whether we should route that to this computer, web 1 or web 2. Does that make it clear? So that's
Yeah,
the
yes, sir.
difference.
Thank you very much, sir.
You're welcome.
Oh, sir, because before I go, sir, before you go, sir, please, I have another
Sure,
question, sir.
sure.
Sir, please, how can I be getting your notification whenever you have a class like this? Because I was able to get it from one WhatsApp group that I am, sir. And another thing,
Okay.
please, I would like to request that if we can be having this kind of stuff, like, how am I going to put it? Like, I'm not saying that I should be every time, but if it is often, so that we'll be able to gain and learn more. But
I hear
apart from
you.
that,
I
I really
mean,
appreciate this opportunity, sir. I really
you're
appreciate it.
welcome.
Yeah, thank you, sir.
Yes, so you're welcome. To answer that question, I mean, right now, just to be clear, this session is actually not hosted by me. At least I know Topman was the one who reached out saying they have this session. I think it's called Code Tribe, right? If I'm not mistaken. Code Tribe community is hosting this session. Yes, great. And I was invited to come and teach. But then I used to do this frequently in my Telegram group. Looking forward to doing them. So if there is any notification, I mean, it's my Telegram group that I use to communicate. So if I'm invited to teach anywhere or I myself am running a session, I'll definitely drop it in the Telegram group and sometimes on Twitter too. But now looking at exactly what happened today, I'm even scared to go share something publicly again. So for me personally, it's on Telegram. And the other portion of doing it often, I mean, I used to do it regularly, like 3 times a week or more when we started ALS. But then, hey, things got tight. I mean, my schedules are very tight right now, so it's not easy for me to squeeze time. Like even today, I mean, it wasn't going to be possible, but then I had to, because Top Man is one guy that I respect and I wouldn't want to let him down. So I needed to be here. Okay, so yeah, going forward, I mean, yesterday I think I started my Friday sessions where we just talk and chit chat about challenges and how to go about them and all. But these live sessions where I teach, now I'm doing it, I'm feeling it, and I may want to start doing them, but I have to look at my schedule. So hopefully, somewhere mid of May upwards, I may start the session. The problem right now is that I am far ahead. I mean, I'm in cohort 7, and I have a lot of different cohorts in the group. So sometimes I don't even know who I'm coming to teach. Do I come to do a session for cohort 7? Do I do a session for cohort 8? Is it cohort 9? I mean, to be able to serve everybody would be very challenging. But essentially, that's why when I host such sessions, we record them and publish them so that I don't have to come and redo the same sessions. Okay. And there's a host of other things. I mean, even outside ALS that I feel that you would have to start getting acquainted to. I mean, practically building projects and all, some things to build up your portfolios to make you job ready. So I've been thinking about all of that, and hopefully very soon I'll start sessions like that where we don't just consider only ALS tax, but then as for me, I don't even come to teach ALS tax. I mean, I teach the concept for you to understand the concept. When you go and battle with your tax, because as a software engineer, it's the concept that matters most, not whether you're able to score 200 or not. So, pardon me when you come and I don't open intranet and solve questions. I don't do that. But once you understand these things, I believe that if you should go and sit by your tax right now, you should be able to do it. So those of you who have already done this project, you could go back now with this understanding, go and read it, go through it, and see exactly how these things connect and exactly where you didn't really understand. You will appreciate it more. Okay, so yes, hopefully from next month, I mean, I'll do my best to try hosting sessions, maybe teaching other technologies that I feel are relevant, helping everyone build a job ready portfolio as we prepare. I mean, the essence is for everyone to go through the program successfully, get jobs as they want, or build their own companies as they want. Yes, I mean, that's my response to that. I've seen somebody ask something about how to join my Telegram group. Okay. Anyway, so it is Ahonia Obed. That's my full name. I love my name a lot, so I keep to using it. Telegram group. Ahonia Obed. .com/telegram group. Yes, so I've put it in the chat. Anyone can join, but please desist from sharing it publicly. At least you all saw what happened today. So that's why I've stopped sharing it publicly so that we don't get invaders. Everyone there should be an ALS student. It's not open to the public. If you want, let me share another link. I have a Discord that is open. That one you can share it publicly. Discord that is open just to chit chat and reflect on the week and the challenges, lessons learned, and also solutions to the challenges that we face. techparty.com/discord should be the link to that. Yeah, so I've said those two links in the group chat. Any other question before I drop off? Top man, you share. Any other question before I drop off?
Hello, Mr. Obed.
Hi, top man. Yeah, you're welcome.
Let's say Mr. Doctor, actually, Dr. Obed. Sorry about that.
I really don't mind the title.
It's important. You worked for it. You earned it. You earned it. Wow. Thank you so much, sir. Thank you so much, sir.
You're
Thank you.
welcome.
We are in the event which I why
Oh, okay.
I should come and express my gratitude for a link. Thank you
Oh,
so much.
that's fine.
I trust that you've covered a lot, and I trust that my colleagues here uh, have learned a lot as well. Thank you so much. I'm really
You're
grateful.
welcome. And thank you too for giving me the opportunity. I
Thanks.
appreciate it.
Thanks. Yeah.
All right. I mean, guys, any final question before I leave? Otherwise, then we'll bring the session to a close. One, two, three. Yes. Sure. Go ahead.
I'm not kidding. Yeah. Okay. Yes.
Hmm.
Okay.
Okay. I, I, are you referring to me personally? Oh, okay. Oh, okay. Okay. So personally, I mean, I love the idea of entrepreneurship. Um, at the moment, I'm trying to build a digital health startup as a side hustle. So that's why I need like a broad. I don't need to be a specialist. I need to be a generalist because I'm starting a company. I need to have like broad knowledge on almost every aspect to be able to run the company and also yeah, and I love knowledge, and I like teaching. So for me, it's a whole thing. Like, I mean, you can't teach when you don't know, right? And I don't want to restrict my teaching so that I'll say, oh, it's only software engineering, just software engineering or front end. Then I restrict my no. As for me, I'm a generalist because one, I'm going to be teaching a lot of these things, and two, I need it in my startup to be able to run the startup. But aside that, I mean, I love web development, right? I want to build platforms on the web, and probably in the near future, it's in fact one of my goals to learn mobile app. I mean, developments, probably using React Native or anything. Yes. So I'm going to keep learning, but for now, more web development and teaching. Yes. I hope that answers the question anyway. Oh, okay. Relax. I'm saying relax, no pressure. Mm-hmm. Mm, interesting. For one thing that I've always desisted from is giving general advice. I mean, I feel that general advice doesn't work. I mean, you give it and you think it's applicable to everybody, but everybody's situation is unique. Like everyone's reason or motivation to wanting to become a software engineer is quite different or unique in their own sense. So I usually desist from it. But I mean, every aspect of the game, you could go for it, right? What you'd have to pay attention to is your own reason for joining. If, for instance, if it is for you to get a job as a software engineer, then now you should start paying attention to what jobs are available where you are trying to get the job. Okay. Like that should be the first thing. So say you are in Lagos, you're trying to get a job in Lagos, then you should now pay attention to in Lagos which types of job are really available. Is it what is it? Is it I mean, front end development or back end development, or are they looking more for cloud engineers? Are they looking for solutions architects? Are they looking for systems engineers? Okay, then you start looking at those ones. The market, what is the market requesting where you are trying to get the job? Then you can narrow down there that okay, I mean, my only reason for doing this is because I want a job. So let me do what they are looking for. Then you go in to do that. Aside that, I think the rest has to do with personal interest. If it is not really for a job, then it's you personally. Which of these things attracts you the more? But until you expose yourself to them, you wouldn't really know what attracts you. Okay. As for me, I like learning, so I don't hate learning anything. Like, hey, today if I decide that I want to go fully into DevOps, I mean, I'll go into it and all. But yes, so look at your own interests, then the market around you, what exactly the market is requesting. I bet that a lot of you have not even thought about it, even though you are looking at getting jobs, but you haven't started paying attention to what jobs are available out there. All right. Which, I mean, if your focus is the country specific focus or a worldwide specific focus, then you start paying attention. Okay. Or maybe find out. Yesterday, for instance, I started reading on the 2022 survey that Stack Overflow did concerning the various programming languages, the various technologies, and all the ones that people are willing to learn the more. For instance, I am interested in teaching, right? So if I'm interested in teaching, I should be looking at what or which of these technologies are people really looking out for so that I can master those technologies and teach them. I mean, if you want to teach, you want to get audience, people who will be watching. You wouldn't just want to create content on something that nobody cares about, right? So that is one. If you are looking for job, you should now be looking at which of the technologies are being hired the more, but more importantly, the specific location. If you are looking for a location-based job, which is usually like the first instance when you are just starting off, right? You want to do something that, I mean, in your locality, you can get a job with it, gain some practical experience, and you can now leverage that to apply for other jobs. So, if possible, if there are meetups around, tech meetups, you can go in or companies, tech companies around you. You could do some search on them, find out what technologies they are using, then start learning those ones. And you can now go and leverage your knowledge and say, hey guys, I know that you've been using this and I am experienced in this, I've built this and that and that, and therefore I feel qualified to work with you guys. If you have an opening, I want to work with you. Okay. And for me, one reason, like my specialty when it comes to programming tech stack, I chose to learn the main stack. Okay. Previously, I did PHP. I learned Laravel as a PHP framework, but I realized that what I really wanted to do, a lot of them had to do with JavaScript. So eventually, I decided, okay, no, let me drop my PHP and learn the main stack. I mean, by dropping it, it doesn't mean I can't write PHP. Anytime I want, I can go, but I want to specialize in the main stack and anything that is related to it. Okay. And one of my motivation, even though I'm not being driven by work per se, But still, it was a motivation that, oh, nowadays a lot of the work requires knowledge in a lot of JavaScript. I mean, web development stuff. So then I settled on that particular one, right? I don't know if it's helpful. Hmm. You're welcome. All right. Is there any other?
Okay, good evening all.
Yeah, again.
Okay, I actually want to ask a question still on the
Sure.
career, yes,
Okay.
aspect.
Sure.
Yes, please. I want to really have an understanding of what it really takes to be a full stack developer. I, I actually have a very, very, very good or solid background in graphics, and then I decided
Okay.
to venture into front end development. But
Mm.
now I am in ALS, and I don't know, I'm a bit confused. I don't really know if I should just continue with my front end dev or I have
Okay.
interest in tech in general. So I just want to understand what does it really take to be a full stack. Maybe that will help influence my decision.
Okay. I
Thank
mean,
you.
yeah, that's very well. I mean, it's in the right, like, I mean, you're in the right order to ask that question, right? Especially if you're coming from a design background, automatically you feel front end is a thing and that's what you should do, right? So essentially, when we say a full stack developer or engineer, we are looking at someone who can handle both. I mean, you could start a whole project and build it. You don't need a third person or a second person to build the back end for you, or you build the back end and the front end. I mean, I could start a project. For instance, at work this week, I had to build a website for something. No, not something I should disclose right now. But then in that building that particular website, I had to do both the front end and the back end. And that is the work of a full stack engineer, right? So if I was more of a front end, then I'll just build a front end, then maybe look for someone else to build a back end. But I should be able to, as a full stack engineer, I should be able to do all of them. If you are just specializing in front end, I mean, if you are the creative type and you want to do it, that is perfect because you are good with designs and all. There are people who will struggle, irrespective of how much they learn about design, they still struggle to even choose the right colors and all. But if you have that skill set and you're specializing in front end, then you can produce designs that people will really love, and that will become a good specialty for you. Okay, but it doesn't hurt to know a bit of back end, even if you are specialized in front end, because that thing that you are building as a front end wouldn't stand on its own. You never build only front end applications, they don't happen. Like the front end, okay, unless you're building a static site that has no dynamic content, but mostly at work you'll be doing a lot more dynamic content, right? So there should be a back end to it. And that means that you should know how these back end sort of things work so that when you are incorporating them into your front end, it becomes easy for you. Somebody who is doing back end, specializing in back end, it doesn't hurt to know what front end is like, or I mean, some knowledge of front end, because when you are building your back end, you should also be able to envisage how the front end developer is going to use the data that you are generating, or however you are presenting your back end, the APIs that you are creating. You should have a fair idea how you want it to utilize in the front end. So it is good for you to have an idea of the front end as well. But then the full stack person is the person who knows both. I mean, I can switch today to be doing just front end. I can switch to tomorrow to be doing back end. If you have the time, I would always recommend full stack if you have the time, because let me explain. I mean, there is an argument. I could even argue it myself about it, but I mean, I've just made a point. So let me explain the point. I would recommend going full stack because, well, when I go full stack and I build applications, I mean, for my portfolio, right now, it is part of my goals that, yeah, top man, that's fine. All right. It's part of my goals that after ALS, probably the next 3 months after ALS, I'll dedicate that to building a solid portfolio. Okay. So if I'm a full stack engineer, which I am, what I'm going to do is, well, I'm going to build projects that are fully like front end based. I'll build projects that are back end based. Then I'll build projects that's like full stack, like so that I can showcase that, hey, I mean, I can do this. And when I'm applying for jobs, which currently I don't have to apply, thanks to God, I mean, so when you are applying for jobs, then you can apply for roles as full stack engineer. You can apply for roles as front end engineer, and you can apply for roles as back end engineer. So you broaden your scope, and whichever one that comes for you, that is fair enough. You go with it. But as I said earlier, this happens if you have the time. If you don't have the time, then it's good to specialize in the parts that you are really good at. Focus on the part that you are really good at, put in the energy, build projects that will wow anybody at all that sees it. So if it is front end, I mean, I want to see that your front end is on point. I mean, the animations, everything is like to an extent that once I see it, I want to hire you, even if I don't have space to hire anyone, right? You focus on that. I mean, if you are more of back end, it's difficult to showcase what you've done. But then, can you build an API that does a lot of work and you probably demonstrate it in one way or the other, record videos and showcase it such that as part of your portfolio, anybody can see the good things that you are doing as a back end developer and they want to hire you when they see that you know the logic behind the things that you are doing. Okay, so in those cases, when you don't have time, you are just focused on one, then you build a project for those ones. Otherwise, if you have enough time on your hands, go the full stack route, but then hey, try building projects that are like specialized projects for front end, specialized for full stack, specialized for back end, and you could now apply for jobs in all three. That's my comment on it.
Okay, thank you very much. I really appreciate your response, and I think they are quite helpful. But one last question: do you think
Oh.
that ALX will actually give me an opportunity to become a full stack developer? Like, do they have all? Am I going to get all the resources I need in ALX, or do I have to start looking elsewhere, like trying to see how I can leverage another resources in addition to what ALX has to offer if I want to go for full stack?
Okay. I mean the interesting bit is that ALS is training you to become a software engineer, right? If you are becoming a full stack engineer necessarily, you don't necessarily even need like the DevOps things that you are doing and all. But I mean, that's if you're talking about web development full stack engineer, right? But you are being exposed to all of these technologies. So as for exposure, you're going to be exposed to as many things that you need to become a full stack engineer. I mean, I'm happy to say that like all of these things you are introduced to them in ALS, right? But to have the skill set to an extent that anybody wants to employ you is totally on you. Nobody can take that bullet for you. I mean, it's totally on you because there are people who go through the program and even the basic things that we learned, they don't even know. I mean, they know how they went through the programs. Okay, so I absorb like in my journey, this is what I've always done. I absorb ALS of any blames, right? And I say, hey, I mean, what do I need to do, right? ALS is introducing me to this HTML, CSS. I don't know which cohort you are in, but HTML, CSS, I remember that the time you got there, it was like 3 days, and I think covered over the weekend. So 5 days in all, including the weekend for HTML, CSS. And you and I know that you need to learn more than just the 5 days. But you've been introduced to it, and you know that if you want to become a full stack engineer, HTML, CSS is one of the things that you need to learn. Maybe those who are doing the front end specialization, they get to do more of HTML, advanced HTML and co. But essentially, what I'm saying is ALS will introduce you. You're in cohort 14. Interesting. I mean, you are now even getting started. So,
Yes.
yes. So, what's going to happen is that ALS is going to introduce you to most all the things, but they can't introduce you to everything, right? Because the tech world is massive, like huge. Things are changing all the time, and they are trying their best. And the good thing is that at least you get familiar with something. Like you get to know that, oh, okay, when I need to build as a software engineer or full stack engineer, I need to know front end. I need to know how to work with servers. And I've been introduced to all of these things. But the practicality of it, to understand that when you go out to the market, you say, hey, I'm job ready. It's totally on you. So that one, you are open to taking as many courses as you want. I can use myself as an example. In December 2022, just last year, when we were going on break, I think the break was on 23rd. I decided to apply for a particular job I came across. The job was asking that you build a note-taking application using the main stack, right, as the technical assessment. So I said that I was going to do it. By then, ALS had only taught us. I mean, we've been introduced to C, we've done Python, and we've done JavaScript, right? And even with Python, at least we had started a framework called Flask, which is for web development. But I, for one, have always wanted to learn more JavaScript. So I decided that, okay, this is a good opportunity for me to now learn JavaScript, start learning the main stack itself. So I learned React, I learned Express.js, Node.js, MongoDB. For Node.js, at least ALS had introduced us in one way or the other. Express, they hadn't. React, they hadn't, and all. But then I took that space. It was within 5 days, right? And I spent that 5 days. I mean, last year I didn't even spend Christmas. Like I was just in my room, locked up myself, trying to learn these things just to be ready for that job, right? And I did learn it, and I was about to put in the application. Unfortunately, they had taken the application off, saying that it was on, first come first serve basis. So they had employed someone. I was like, okay, no problem. At least I'm happy I learned these things. By January 1st, a colleague of mine reached out saying, oh, there is a freelance contract that we are working on. Could you possibly join the team as a backend developer? I said, oh, which tech stack? They said they are using the main stack. I said, yes, I can join. I mean, I can hop on as a backend engineer. We hop onto a meeting, discuss the terms, and eventually I started working on that project as the sole backend developer on the project. And this is something I just learned how many days ago? Some few days ago, because I wanted to apply for a job. But then ALS has given me that capability of doing hard things, right? I mean, you see something challenging and you want to take it on. I saw it as a challenge and I wanted to take it on. And I say the rest is history, right? I now that's more of my specialty. I mean, and I'm looking forward to even getting far better. This week, I've started learning Nest.js, which is like a framework for React. So I'm trying to further my knowledge in the main stack, right? I've started learning Material UI for React, that is design part and all. So I feel that that's the route that you are going to go. ALS is going to expose you to them. It's going to teach you how to learn by yourself, and eventually you choose what you want to learn to make yourself ready. But then you should keep your ears on the ground because things changes. I bet you that in the next 1 year, a whole lot is going to change, right? So what you think is relevant today may not even be relevant in the next year. So you keep your ears on the ground to listen, and you follow the. I mean, with now tech is always on the rise, right? So follow this, right? Wherever they take you, you learn what you need to learn to get to the job now. Yep.
Right. Thank you very much. I really appreciate. Thank you.
You're welcome. All right. So I think we've done enough. We'll probably have another session some at that time. I mean, I'm quite tired right now. So thank you all. Hopefully the recording will be made available. Those who missed or didn't join on time can always have access to it. And I look forward to having other sessions later. Favor, your hand is up. All right.
Good evening. Good evening. Sorry, I wanted to ask, like, though it's just the question is not long. As a front end developer, can someone venture into, like, instead of going to back end? I love this DevOps like mad, like it's driving me crazy. Is it possible for someone to be a front end developer and at the same time doing DevOps, all these servers and all these constellations and all these
I
things?
mean, I mean, at the end of the day, it's totally up to you as an individual. Now, I'm a solutions architect. I hold a certification in AWS solutions architect, but then I'm also working as a software engineer, right? So it's totally up to you. And even DevOps is one field that I also enjoy and I want to look forward to learning it. But as I keep saying, it's about time. If you have the time to learn it, nobody should stop you. Go learn it because now it opens a lot of avenue for you. I can apply for jobs as a solutions architect. I can apply for jobs as a front-end engineer. I can apply for jobs as a full-stack engineer. And if possible, apply for jobs as an entry-level DevOps engineer. Okay. So it's totally up to you and what you want to do. If you have the time, learn as many things as you want. If your goal right now is just to get a job, focus on the smaller parts that you can learn. Learn those parts, become the specialist in those parts. Use the time to apply for a job, and on the job, begin to learn any other thing that you want to learn. So that's allowed. All right, maybe some other time we'll have career sessions. I mean, I hate to teach things that I don't practically use. Like every time I'm sharing something, I want it to be like something I've experienced before. That's why I don't delve into such sessions. Otherwise, I would have. I mean, if you ask me some of these questions, I'm sharing my personal opinion. I could be wrong, and I accept that, right? But this is what I think, and this is what I'm doing. Then I share with you that this is what I'm doing. But because I haven't been in the industry for years, I mean, I haven't gotten jobs for years. Who now come and say, oh, when you are looking for a job, this is what you do. I mean, everything I'm sharing is probably something I've learned or something I'm trying to do. Okay, so if only you people don't mind, I mean, we could host sessions to discuss career wise stuff in ALS and all. And yes, I mean, someone is asking, glad I attended this session. Okay, that's good. Yeah, so guys, let me, please release me. Let me vanish and we'll meet some other time. Okay, thank you all so much. I mean, I really appreciate it. I don't take it lightly for you to spend your time with me at this time of the day. I mean, it's a weekend. I appreciate you all and thank you so much for showing up. So,
Thank you, sir. Thank you, sir.
welcome. All
Thank you
right.
very much, sir. Have a good night rest.
All right, you
Thank you.
too.
Thank you,
All
sir.
right. All right. Bye bye.
Bye.